Hello, everybody. Welcome to another webinar in the Connection Wednesday series. And it is great seeing that many of you here. And this one is going to be a bit unusual. We already have 215 attendees here, which is great. And we are very excited. And why is it unusual? It is because of the topic connection automation. This is the first webinar on this topic. So let's perhaps start with introduction. Let's introduce our speakers today. So starting with Nathan Luke, our BIM specialist joining from Melbourne, Australia. Nathan, since this is your first appearance with Idea StatiCa on a webinar, would you be so kind and introduce yourself for a bit?
Yeah, thanks, Wojciech, and it's good to be here. My first Idea StatiCa Connection Wednesdays. So I was 7-8 years as a structural engineer with Oricon in Australia and Bureau Happold in the UK, and then have also worked with Geometry Gym for 3 years as a sort of a developer and support, mainly around Rhino Grasshopper. And connecting FEA and BIM applications together. So I've been with Idea StatiCa as a BIM specialist for the past 6 months. And yeah, looking forward to the webinar.
Thanks a lot. We are happy to have you on board. And we also have a special guest here with us, Ryan Ajus. I believe many of you might already know Ryan, but for those of you who don't know him, Ryan, if you are with us, could you tell us how are you and what do you do?
Yes, now I'm hearable, I guess.
Yes, we can hear you.
Okay, great. Thanks for having me today, Wojciech and Nathan. My name is Ryan Ajus. I am an automation specialist working at Bouwme Staal. Bouwme Staal is the branch organization representing the steel construction industry in the Netherlands. I'm actually also from the Netherlands, by the way. And what I do there is I develop tools like KarambaIdea together with Wojciech and Nathan. And we also try to promote computational design within the Dutch building industry. For the rest of the week, I work at ABT, which is a multidisciplinary engineering firm. And there I work as a structural engineer, where I can actually put into practice what I preach at Bouwme Staal.
Awesome. Thank you for that introduction. Also happy to have you here with us and looking forward to your introduction of KarambaIdea plugin later on. And that leaves me. Wojciech Chalupa, I'm a product owner with Idea StatiCa. I have background in structural steel design and I have the pleasure of taking you through the webinar today. Just before we start, as usual, you are muted, but you can ask us questions throughout the webinar, and we will try to answer most of them. The easy ones we will answer right away. The more extensive ones you will get your answers to later after the webinar is finished. So before we start, as I said, there is a lot of you joining us today on this interesting topic. Nathan, could you introduce our first poll so we get to know our audience a bit better as well?
Yeah, no problems. So we just wanted to do a quick poll. And what is your main area of interest? So what brings you here today, or what do you do day to day? So is it global structural analysis? Are you more involved in the computational engineering space? Are you involved in detailing and fabrication, or research and academia? Or are you sort of working day to day on interoperability and BIM types of things? So please choose one, and we'll start to get the results in soon.
Yes, the results are already coming in. I will just leave it on for another 10 to 15 seconds. Also, 80% of you have already voted, so that's very good. And another 5 seconds and I'll close collecting the responses. Very nice. I believe most of you had a chance to vote, and looking at the results, we have the majority of global structural analysts, engineers, but also 20% computational engineers. So that's very good to see. And you are here, you are at the right place at the right time. But I believe no matter your specialization, no matter your main area of interest, I promise you will take something away from this webinar, something interesting. So thank you once again for the introduction. Thank you for the poll. And what exactly is the agenda today? So what can you expect? First, we will talk about connection design automation and what that really means in the context of IDEA StatiCa. Then I will introduce the IDEA open model and our plugin, the API, and also introduce the concepts behind developer mode, templates, parameters. Then it's Nathan's turn to do an example. He will do an example on weld optimization of a hollow section joint. And then we'll hear from Ryan about the KarambaIdea plugin and also another example. Nathan will show us how to use visual programming with the IDEA open model and the API. So without further ado, let's jump right into the first topic. If we have time at the end, we can do a short Q&A session too. So connection design automation, what do we mean when we say that? Well, it is a process in our eyes that helps you get from your global structural model to a connection design that you are happy with in the least amount of time and with the least amount of boring, mechanical, repetitive work. You don't want to be retyping values and pushing buttons. You want to focus on the creative aspect. We've identified a couple of intermediate steps in this process. First, you have your global structural model, and that needs to be somehow translated into something IDEA StatiCa can understand. Then you might do your first design and you will probably not get the optimal one right away. So then you need to iterate and optimize to get to your final design that you are happy with. And finally, you are left with a well-designed connection, hopefully. The understanding part is facilitated by the IOM, IDEA Open Model, which I will talk about in a second. And the design part, the optimization part, is enabled by our API, by the IDEA plugin. So now I guess we should start unpacking this one by one. So what is IOM exactly? IDEA Open Model is an open source C# framework, and it can describe structures in a way that IDEA StatiCa can understand them. Here you see our GitHub page, and you are more than welcome there. You can find all the relevant links on the landing page of the webinar. So if you just go to our support center, webinars, find the page you registered on, it's all there, all the necessary links. And so what does it contain? I said it is a description of a structure. So what exactly is there? Well, firstly, the nodes and structural members, their directions, local coordinate systems, etc. The base underlying geometry of the model. Then the cross sections and materials that are used are also inside the IDEA open model. Also, there are internal forces, and we use these as actions to then load our connection models. And the IOM is also capable of storing the connection parts, not the actual manufacturing operations that you would use in connection if you are a user already, but rather the basic components such as plates, bolts, welds, and cuts. And all of this can be represented as a human readable file, XML, a part of which you can see on the left here with the project origin settings, a couple of points in space representing the nodes. Then you would have lines representing your center lines of the members, etc., materials, everything that you see here on the right. So this is IOM in a nutshell, a file containing a description of a structural model. Now, I just want to briefly mention templates. Templates can be used to transfer manufacturing operations. Now I'm talking about the ones you interact with on a daily basis in the app. So end plates, wideners, between IDEA connection files. So in the template, the information about the operation is stored, about their sequence, and therefore basically about the whole design. So I can have a naked connection on the left and apply a template on top of it and receive a designed connection, receive my first design through application of the template. Parameters are another very useful tool, mostly for optimizing. They are available in the developer tab in the connection app, which by default is not visible, and you can learn about accessing it on our GitHub wiki. The link to which is at the bottom of the page, but also on the landing page of the webinar. Parameters basically allow me to modify properties of the connection model. So here I've created two parameters and linked them to the thickness and the weld size of the stiffener to manufacturing operation in my model. By changing these parameters either manually or through code or a plugin, basically our API, the model will then also change. Don't worry if all of these concepts are too much to take in. Nathan will show this in his example in a minute, and it will all become quite clear. But last thing before that example, and perhaps the most important part, the IDEA StatiCa plugin. This is basically, as I said, our API, and you can use it to take the open model file and generate and save an IDEA StatiCa project file with the IDEA.con extension. You know these files very well. These are the basic connection app project files. You can then use the plugin some more and interact with this file in all sorts of ways. You can apply a template, you can update loads, set your parameters, and of course, run the analysis and read its results. The plugin and its calls can be called using Python or any other language, and it can be integrated into your visual programming tools, such as Grasshopper Dynamo. You can use it through Jupyter, Excel, etc. We will be demonstrating all of this using a C# code, but don't worry if you've never seen Visual Studio before. You don't actually need to know the ins and outs, how to write the code in order to take advantage of all of this. There are tools that you can download that will be developed or are developed already, such as the KarambaIdea plugin, for example. So hopefully I managed to explain the difference between the IOM and API. While the IOM defines a complete model representation, API allows you to interact with it. You don't actually need an IDEA StatiCa license in order to generate IOM, but you need it if you are using the plugin and its calls, because they are using IDEA StatiCa in the background. You can also take advantage of our NuGet packages for the open model as well as for the plugin. And now, last slide before the example, coming back to my first slide, showing the steps you might take manually when designing a connection. You can now take another look at it, now using automation. So you would use IOM to translate your 3D model into IDEA StatiCa, not retype the geometry into IDEA StatiCa, not select the cross sections of the beams, material properties, etc. Then you would use the plugin to generate an IdeaCon file and perhaps apply a template to get your first design in. Then by getting and setting the parameters, changing them around, you would arrive hopefully at your optimal design. And once you have that, you might want to export the results, for example, again, using the plugin. But I guess enough talking. Let's see it all in action. I'll hand it over to Nathan, who will go through our first demonstration here.
Thanks, Wojciech. And I'm going to go through an example today to try and demonstrate those workflows that we've been discussing. So I'm going to start with a project like this, and maybe this is a design project, a design connection project we've done somewhere else on the same job or on another job. And we've got a couple of operations here which relate to cutting of these tubes with different weld thicknesses and stuff like that. Maybe we have a similar topology somewhere else on the project, or maybe we have 50 connections that are all similar, but with slightly different geometry or loading or member sizes, and we want to reuse these operations. But we also might want to be able to change these weld thicknesses as well to sort of optimize the welds for the given geometry or topology. So in this file, I can go to the developer tab and we can see that I've created a couple of parameters here. And these parameters are number parameters which basically relate to thicknesses of the welds. And I've created the parameters on the left-hand side, and on the right-hand side is where I relate that parameter to a model property. So I can click on this parameters in model or the model properties, and under the cuts you can see that there's a weld thickness parameter that I can set. So I can demonstrate changing one of these values and then clicking set to model to demonstrate how that weld can be changed using parameters. So I want to be able to export this as a template so I can then apply it to an IOM generated connection file. And under the templates in the developer tab, there's a save as button. So we're just going to save that as a template, and I'm just going to override the existing one I've created earlier. And we'll see later how we can use these to start to build connection files that we can optimize. Okay, I'd like to introduce you to a project, a Visual Studio project that I've created, and this is going to help us automate the creation of the IOM, the application of the template, and do a weld optimization using the parameters. So I'm just going to look quickly at this project and how it's set up. So it's a .NET Framework project, and it's a console application. So console application basically means I can run the project directly from here, and the code in the main method will basically be run. It's a reasonably simple project with just one other file for an optimization parameter, which we'll talk a little bit about later. The dependencies here, you can see the packages or the references that are installed with the project. These are installed via NuGet, and that's how we distribute our APIs. And you can see that the StatiCa plugin is installed here. You can also see that the StatiCa plugin is referenced in this program file. Just quickly to show you how to have a little bit more of a delve into the plugin and what's available within it. You can go to the object browser, which is available in the view toolbar, and you can see under Idea plugin that there's a whole bunch of items that are available in this DLL. The main ones we're going to be looking at today are the Con Hidden Client Factory and also the Connection Hidden Check Client. Now the Connection Hidden Check Client is basically the class which allows us to interact with Idea StatiCa connection. It has a whole bunch of methods that allow us to open projects, add things to projects, get things from projects, and also apply templates. So let's jump to the example. And in the main method, we're going to basically, the first thing we're going to do is create the client factory. And this is a reference to the program path or the path of which IDEA StatiCa is installed. In this instance, we're going to use IDEA StatiCa 22. I would definitely recommend to download the latest version and use that. The Calc Factory allows us to create clients from it. So we can use the calcfactory.create method to basically provide us with a client, and the client is what allows us to interact with IDEA StatiCa. For this example, I've created a folder reference, and if I click in this folder, you can see the files that are in there at the moment. So I have an IOM model file, which I might have got from an FEA conversion, and a results file as well, and the template file that we created before. So the first thing we're going to do is create that IDEA con file from the IOM. So it's as simple as using the method available in the client to create the connection project from IOM. We specify the model path, the result path, and also the path where we want the IDEA connection file to be saved. Secondly, I'm going to apply a template to that file. So I've obviously got my IDEA template path from before, and I also want to specify another file path where I want to save as that applied template to. This method, the create connection project from IOM method, does not keep the project open. So that means we're going to have to reopen the project before we want to apply the template. We simply need to get the first connection in the connection project, and this is just because IDEA StatiCa allows you to have multiple connections within a project. In order to apply the template, we're going to use client.apply template. We're going to take that first connection that we've received and provide the identifier for that connection. We specify the IDEA template path and then some template settings as well. I'm just using the default settings here, but you can have a play around with this. We're then going to save as the project. We could save it if we wanted to, but I want to see the difference between the two files at this point. And then finally, I'm going to close that project again. All right, so I'm going to run the first two parts of this by just clicking the Run button. And this is going to open the client, create the connection with IDEA StatiCa, and then create that file. So I can see now that the file has been created if I click on this folder, the tube connection. And then if I go back to this console, I can press the next key, and then I can see that the template has been applied. I can go back to the folder, and then I can see that I've got my connection template that has been applied. If I open both of these files, I can see the difference between them. So the first one will have none of the operations assigned, and that's just the file that's going to come from my IOM and my results file. So I'll just wait for that to open. This is this one. So you can see that I've only got my members or members and loads and unbalanced forces, which is great. The second one that has the template applied, I have my operations now defined, and I also have the parameters that are assigned as well. So this is the file that we're going to start to do some optimization on. So now let's look at how we can use these parameters to design each weld as we go through a weld optimization procedure. So if I go back to the code now, I'll run through this quickly and then we'll run the optimization. But again, we need to open the project using the client. And what we're going to do here is we're going to get the parameters from that project. And then each parameter, I'm going to basically wrap that in a weld thickness optimization parameter, which I've created. And this little class is going to basically update the value of a parameter as it goes through. So if I click and have a quick look at that class, I've basically got an initial value that I want all the welds to start with.
and then a value that I want to increment it by if the weld isn't satisfactory. I'm also setting a max value here as well. I go back, so I've got 3 of those, and they are just referencing the parameter names which I've set up in the project. A couple of other options I've done on this optimization procedure is basically whether I want it to save after each iteration, and the maximum amount of iterations I want as well. So it will be a for loop. It'll just be a for loop, and at the start of each loop, it's gonna we're going to be able to set the value of that parameter, run the calculation, and then test to see whether the parameter is designed adequately or whether it needs to be increased. Okay, so I'm just going to run that, and so if I go back to the console, I can click again, and this is going to start the optimization. And you can see on the first iteration, I've set all the parameter weld thicknesses to 3 millimeters. And after the first run, you can see that all the welds are unsatisfactory. So we're going to increment them by 0.5 of a millimeter for iteration 2. Again, all the welds are unsatisfactory, so we'll iterate them again to 4 millimeters. And you can see after the third iteration, the column weld has actually been optimized. So that's going to stay at that, that 4 millimeter value, and then the other ones have been incremented up. You can see again, after the fourth iteration, the chord welds still haven't been designed adequately, so they've been iterated again. And then finally, you can see after the fifth iteration, all the welds have been optimized. So I can click into that folder, and you can see the iterations there. I can double click on that last iteration. This should be our fully designed connection. And you can see all the welds, all the welds for the cuts have been assigned as designed. I can calculate that now. And you can see that all my welds are within a good range of design. So that's the end of this this example. Hope you've enjoyed it, and I hope you can sort of build on this for future. So I'll pass back to Wojciech now, and he'll continue.
Very good, Nathan. Thank you a lot for your example. We have noticed that some of you have lost sound during that example, and we are very sorry about it. Please follow Adam's advice, and if that doesn't help, the recording will definitely have the sound. So once again, we are very sorry about that, and hopefully this is not affecting a lot of you guys. Before I hand it over to Ryan, we would like to have another poll, and this time ask you about your computational experience. So I will just quickly run the poll, and let's have a look. Do you use Excel spreadsheets? Do you use macros, VBA scripts mostly? Do you do visual programming, Grasshopper Dynamo? Or do you actually have a basic knowledge of a programming language? Some of you joining might already be full-time software engineers too. So again, I'll let this poll run for a couple of seconds. So everyone.
It's good to see that some people have got basic knowledge of programming language.
Yes, yes, indeed. I'll share the results with you all. And indeed, 31% of our audience have actual experience with a programming language.
That's good. I hope people understood what I was showing people.
That's right. Very good. Thank you for your answers again. And now I will hand it over to Ryan to introduce the KarambaIdea, to introduce the past of the plugin and perhaps the future too. So I am unmuting you now.
Yes.
Very good.
Yes, I'm back again. Yeah, thanks again. I guess it's really important to also take a look at the bigger picture we have here, and what connection automation can really do for us. Traditionally, when we design a structure, designing the global structure and the detailing is separated, and this may result in conflicts in a later stage, because generally the steel contractor who fabricates the joints designs it. But when you designed the global structure to slender, you might end up having connections that are not possible to transfer the forces. You need to increase cross-section sizes, for example. At that moment, increasing a cross-section may result in a conflict with a channel going underneath the section, or the floor height is adjusted, which will result in a conflict with an architect. Secondly, both engineering work you actually want to have them designed under the same philosophy, so that your connections line up with the assumptions being made in your global structural analysis, so that the actual behavior of the structure is as intended. With automation, we are actually able to automate this whole procedure, making it possible for one person to be in charge of both works. So you are then responsible for designing the structure, but also assessing all the connections that are occurring in that typical connection or in the typical structure. If you compare it with what is being done in computational design now, often is that geometry is altered, and with a size optimization algorithm, the weight is optimized. But what we are advocating is to do not look only at a global structure, but make an integral analysis of both the global structure and all the detailing. So afterwards, you have much more information aside from just the steel weight. You have information about welds, about the number of bolts, so you can express your variant in terms of costs, or even in terms of sustainability. And in that way of working, we will probably be able to create more better structures in general. So in this story, where does KarambaIdea start from? So I actually started with this topic during my graduation project at TU Delft, and when that was finalized, I was asked by Bouwmestijl to continue my graduation project, because they acknowledged this problem within the industry, and they saw this as a potential solve to produce a tool that would help engineers combining detailing with their actual work, and automate it a bit, because it's very repetitive. A lot of connections are similar in your whole structure, so it's great to use in computational design procedures. So one of the delivery keys I had to deliver was building a plugin, and that's actually where KarambaIdea started from. So I refactored the code I used for my graduation project and make it more generic, so that people could use it for any type of structure. In this case, basically making it applicable for 3D structures. But back then, it only was able to export connections, like base connections, so no design involved whatsoever. While time progressed, the plugin progressed as well. So in 2020, we had version 2.0, as I would refer it to. So you would be able to assign an existing template. You would not be able to modify that. And if you want to do something dynamically, you could do it with coding, but due to coding being more, not for the general public, the chances of the plugin being used in that way were slim. Now we are working on the 3.0 version together with Nathan. The plugin is really going next level. His help and insight and his experience he had built up at the Geometry Gym has so far been really helpful. Currently, a new version is downloadable, but it's still under development. But we didn't want to tease you with showing what is possible and not giving it to you. So keep in mind that it's still a beta. But in my experience, what Nathan is going to show you now is going to be really, really exciting. And hopefully, if you have any questions or suggestions, please contact us, because we will try to process your thoughts and remarks. And the common goal we have is to make the plugin as best as possible.
All right, Ryan, thank you very much for that introduction. We are very happy for this collaboration, and we hopefully it will continue to be as fruitful as it is as of now. And as Ryan said, we should just jump into the second example, where Nathan will show the capabilities of visual programming of linking Grasshopper to IDEA StatiCa plugin.
Thanks, Ryan, for that introduction, and thanks for letting me go through some of the amazing stuff that you've done with KarambaIdea. So today I just want to go through a quick example, and I really just want to demonstrate some of the enhancements we've made to KarambaIdea. And typically they are around the API calls that are available in IDEA connection now. So once you create your IDEA connection, how can I start to interact with that through the API and also in Grasshopper? So some of the things to start are, connection costs, obviously connection results, but also, modifying connection parameters as well, along with some enhanced template applications. So today I just want to go through a simple truss example, and if you're not familiar with Rhino and Grasshopper, Grasshopper is a visual programming tool or interface that allows you to create geometry and use its parameters to, I guess, modify it. So this particular example's got a length that you can modify. I could also modify the divisions in the truss if I wanted to, the height of the truss. This example here, I've also allowed for the location of the kink, and I also wanted to demonstrate the ability to sort of locate truss splices as well on this truss. So where do I want these trusses, splices, or and how can I move them around? And you can see the connections being added as well. So I'm not going to go through the geometry creation in any great detail. This example will be available, so you can have a play once you have it. So I guess once the geometry has been created, Karamba 3D, which is a plugin for Grasshopper, allows you to generate that structural analysis model and also sort of do your real-time structural analysis within Grasshopper. And one thing that allows you to do is create groups of members. So if I've broken up my geometry creation correctly, I can start to assign these to groups. And in this example, I've broken up the different groups in column, top chord, etc. And mainly, one of the other things I've done for this example is split the diagonals into a diagonal member and a splice member. So where the diagonal occurs at the splice location, that's going to be grouped as a different member, and that's going to tell the logarithm that categorizes the connection that, you know, that's a different connection type, and I might want that to be bolted rather than welded. So once the structural analysis model has been created, we can start to use KarambaIdea to start to work with IDEA StatiCa. So if you've used or seen some of Ryan's examples in the past, he does a conversion for us using the create project component, and there hasn't been much change in the create project component. So that's still very similar. And what that's doing is taking that Karamba 3D model and converting it into basically an Karamba IDEA project, which we can start to use to create IDEA static connection files. Just before I get into the more advanced Grasshopper stuff, I want to show a component that we have added as a part of the recent enhancements, and that is the export to model BIM. And what this does is directly exports an IOM or model BIM file, which can be imported directly into Checkbot. So I've just opened Checkbot here, and under the import tab, I can import this IOM, and I can basically import my model BIM file. And what this is going to do is automatically create all the connections for us. So if you've done your structural optimization already and you just want to work on connections, or you want someone else to work on your connection design, you can do this and manage your IDEA connections, you know, natively within IDEA Checkbot. So going back to Grasshopper, and one of the major changes that we've made to the plugin is to be able to now deconstruct this project. So instead of using or saving connection files at the project level, we can now start to work with joints in more of a tree type structure. So the deconstruct project component allows us to import that KarambaIdea project and get a list of the joints available. It also can provide a list of all the brand names or connection categories that have been created based on this create project component. So this allows us to work with joints more flexibly. So I still want to use the brands that have been assigned to the joints in this instance. But what I want to be able to do is reconstruct the trees, because I want to work with them in more of a. I want to work with each of the category of joints. And so using some Grasshopper magic, I can then reassign all those joints into lists based on their brand. So you can see here I've got two joints of brand 0, and they're obviously my bases of my columns. And I've got 8 joints of my 1145, which is my top chord my top chord connection. For this example, I really just want to work with my top chord connection category. So I'm just going to take a tree branch now and select my connection category and put in my 1145. And this is mainly just to reduce the calculation time down the line. Now, what I also want to do is I kind of know this truss is it's just a one-way spanning truss, so I know that my that it's going to be reasonably symmetrical, and my joint 7 is probably going to be the most critical of this 1145, and joint 12 is probably going to be the least critical. So what I'm going to do here is I'm just going to take out all of those joints. I'm going to split them in half, and then I'm just going to take the joint 7 and joint 12. So those are the ones I want to work with in this for this example. So I've created a template for my top chord joint, and it's going to be reasonably similar, but what I've done with this one is created a couple of operations. You can see here I've got a stiffening plate um, that I've added, and obviously my post or chord and my diagonal. But what I've done in terms of parameters here is I've tried to create a template which can allow me to have, I guess, a maximum sort of connection type, and then maybe more of a minimum connection type. So maybe I only want to put this stiffening plate on where the loads are very high, or where the loads are low. I don't want this stiffening plate at all. So what I've done here is I've created basically a Boolean parameter, named it stiff plate, and what I want to do is if that is set to true, then I'm going to have my all the operations that relate to that stiffening plate as active, and if not, I'm going to have that stiffening plate removed. So um, I can change this to false, and then I can set this to model, and then you can see that basically my connection is going to change to just a welded type connection with these members just coming in. So maybe I want to be able to change those parameters to change how my connection might interact. I've also again uh, allowed the changing of the post and diagonal weld sizes. So in order to assign that template which I've created, I've exported that as I did before, and I've just saved that in that folder. So I can use the import idea template component, and I can import that into Grasshopper, and I can also now start to deconstruct that template, so I can actually see what parameters are available in there. And what I might want to do is at the creation of that idea file, I might want to set how I want the parameters to be assigned. In this case, I'm just going to stick with what is available in the template, and all I need to do is do an assign or assign the template to the connection, and you can see here that I could also provide parameter modifications that I want to apply if I wanted to. But in terms of this, I'm just going to use a modify joint component. I'm going to take the joint and then I'm going to assign that template to it. I could change the name or a couple of other things that will be available in the future as well. So one of the other enhancements that we've made here is we've split apart the create idea file with the connection. So I can go ahead and bake those connections now, and you can see that running idea StatiCa pops up. So you can see that the connections have been baked, and I've got my idea connection C7 and C12, and the modified basically just means that there's been a template assigned. So it's similar to how it was before. So I can go into my working joints here. I can click on the brand, and then I've got the two joints in here. So you can see, similar to before, I have my IOM and my IOM results, and I've got my my connections as well. So I can click on this, and you should be able to see that I now have my template assigned and operations. Very good. So I'm just going to close that again. And now what I want to do is be able to calculate that component. So first, I'm not going to do any modifications to it, but I want to calculate that and see how the base template works, for those two extremes of the connection. So those have been calculated, and you can now use a connection results component to basically get the results of each of those connections. And then you can also use a deconstruct item result. If you want, you can also, the result output does come out in JSON, so this is kind of how it's displayed as well. So in terms of the connections, I can see that the check status on these connections, the connection 7, I see that my welds are failing, and in here I can sort of see where you know the the some of the welds on SP1 are not being checked correctly. If I look at the other connection, that seems to be going fine based on the plate, the stiffening plate being added to the connection. So what I'm going to do quickly is just show how now we can change some parameters within Grasshopper. So once that file has been created, what I can also do is deconstruct some of the information that's extracted from IDEA when that's baked. So one of the outputs here is the parameters, so I can actually see now in this connection that I've got these parameters I can start to play around with. Obviously the stiffening plate and the chord weld and the diagonal weld. And I can modify these parameters without actually having to rebake that connection file from Grasshopper. So for instance, now I'm just going to see, all right, what if I update the connection welds for that extreme case connection, and I also want to see what happens if I remove the stiffening plate from the lower force connection. So I can update those welds for that. I'm going to keep the stiffening plate for connection 7. I'm going to remove the stiffening plate for the other ones, and I'll update the welds to 0.005. So I can set those parameter values. I can then go in here and modify those, use the modification, and what that's going to do is apply those modifications, and then it's going to rerun the calculation. So that calculation has now been rerun, and we can see that both connections are passing. So the connection 12 actually doesn't need that stiffening plate. So we can go in and go back into the joints, and I can open up connection 12, and I can open up connection 7, and we can just see that everything's been done correctly. So for connection 7, that you can see that the cut welds have been applied, and then if I go back to connection 12, you can actually see that the operations for the stiffening plates and cuts have been removed, and I can start to look around, and you can see that I've just got simply welded connections here. So that gives an introduction to some of the improvements that we've made in Grasshopper, and I'm very interested to see how you guys might take this and start to look at different ways to sort of use it to optimize structures and connection designs. So I'll pass back to Wojciech now, and thank you.
Very good, Nathan. Thank you very much. I couldn't have said it better. We are quite excited and interested in what you can make of this. And to allow you to do that, join the GitHub. If you are interested in this, if you are excited about this, join us on GitHub and post any questions or requirements you have regarding these workflows in the discussions tab. If you find a bug or an issue, use the issues tab on our GitHub and we will look into it. And of course, the wiki will prove an invaluable resource to you if you are just starting developing something using IOM and the IDEA StatiCa plugin. If you perhaps are a developer looking to create a tool, perhaps need some more guidance after reading the wiki, don't hesitate to get in touch with us directly on LinkedIn, for example, and see if we can help kickstart that. I guess we could now, we still have a couple of minutes left, we could answer some of the questions from the audience. So Adam, if you have some interesting questions, go ahead. Just in case you are saying something, you are muted.
Yes, I'm sorry for that. Hopefully you can hear me now.
Yes.
Okay, so greetings to all our attendees today. Thanks for coming. We've got a pretty bunch of questions, so let's bite through them one by one. I've picked a couple of the most interesting ones for all of you. So question number one. Sometimes we want to have access to accurate results. For instance, stress at certain point, displacement in a node, etc. So very special results, accurate. Is this accessible using the API IOM?
So I can answer that. No, you can't actually go into detailed results on plates, but you should be able to find anything that you can usually find when you are using the connection app as a standalone. So you will get your extremes on the plates, but you can't at the moment define the precise locations of where you want to read the results from.
Yes, thank you, Vojta, for that. So another question. Standard Karamba is not needed. Only KarambaIdea is needed for this IOM.
Yeah, very good question. I didn't mention it in my slide, but I initially decided for the name KarambaIdea at the start of the plugin to get a user group immediately, because people would know what the plugin would entail. But actually, the Karamba is not really needed to use this Grasshopper plugin. You can use any FEM model you can think about, and you just have to assign the right information. So you could use SIA engineer or RFEM. It doesn't really matter. You just need to assign the information properly at the create project component. So KarambaIdea does not seem to be the best suitable name now, and maybe in some time we will change it to something else, but we'll see.
Vojta, can I ask you to show our attendees where they can get the KarambaIdea? They can download it for free from the web page of this webinar.
Yes, there should be a link at the web page of the webinar where you can
we can see now the presentation Q&As.
Yeah. Okay. So sharing the
browser. So it's ideastatica.com, support and learning, and then webinars, right? And there you find this one from today. And if you scroll down, there is a list of resources and links to downloads of KarambaIdea, downloads of examples from today's session, and many more. So all prepared there for you, right?
That's exactly right.
Very good. So here you can find this. We've got a lot of questions about resources for today's webinar. So hopefully this helps a lot of you to see where you can find that. Also, the recording of this webinar will be placed on this page as well as on our YouTube Idea StatiCa channel. You can rewatch this on that page. Cool.
Okay.
Any
other questions? Yeah.
Two more.
Let's do two more then. Okay.
Yes, two more. So there is basically question: if the IOM model can also work with the applications for concrete, like RCS, Beam, etc.
Yes, yes, it can. There are already possibilities to interact with RCS through IOM. We might as well make a webinar aimed at this. Make sure if you are interested in these applications for concrete as well, at the end of the webinar, there will be a survey and you can check a checkbox saying you are interested in these workflows for concrete. So make sure you do that, and we might meet again on a concrete webinar that has to do with automation.
All right, up to you. If you vote, then you get it. All right, last question. Not so running out of time. How do I activate the developer tab? How do I access this in the software? Probably a couple of of attendees missed that during the webinar.
Okay, so it is also in the links on the website. So when you go to our GitHub page, Idea StatiCa public repo in the wiki, you can find all sorts of resources, and one of them is Developer Tools Access. So if you click this, you will learn how to manipulate the config file in order to see the developer tab.
Very good. All right. Okay, Vojta, thank you for answering the questions. I will pass the word to you now, probably, to wrap up this webinar, right?
Since yes, we are running out of time, but I think we have managed to communicate everything and also answer a couple of very interesting questions. So I'd like to thank you all so much for attending. Just a reminder, there are some more webinars coming up. So July 12th, Concrete Summer Series for beginners, and September 14th, another edition of Connection Wednesdays. And just before you go, a brief reminder, there will be a short survey, as I mentioned already, after the webinar. Answering that will help us a lot with the next topics of automation. You can find the recording, as Adam said, at the support center, and you can also find all the links there. So examples, downloads, etc. So just visit our support center, learning webinars, and you will find the necessary links there. So that is it for me. Nathan, any final words?
No, not really. Yeah, thanks for joining, and hopefully you found it interesting, and really excited to keep developing these types of things with the community.
Awesome. Thank you all for joining, and have a great day.